researchers, policymakers, industry professionals, and climate advocates. Thank you for joining us today at this important workshop on nature-based solutions for passive cooling. Jointly organized by CIB Task Group 97 and the Passive Cooling Working Group, which is jointly established by UNEP-hosted Global Alliance for Buildings and Construction, or GlobalABC, and Cool Coalition. My name is Gennai Kamata. I'm from the Buildings and Cooling team at UNEP Climate Change Division, where I coordinate the Passive Cooling Working Group. Today, I'm deeply honored to address this workshop as we explore one of the most critical topics in our fight against climate change, which is how passive cooling and nature-based solutions can transform our approach to cooling our buildings and cities without further burdening our planet. What is the challenge we face? The urgency of addressing cooling cannot be overstated. The year 2024 was the hottest year on record. 815 million urban residents had a high risk of heat-related deaths, illness, productivity losses due to rising temperatures and lack of access to affordable and sustainable cooling. Urban areas are warming even faster, twice the global average rate. With this trend, mechanical cooling accounts for a fifth of the total electricity consumption in buildings worldwide, or 10% of all global electricity consumption. Without further action, cooling-related emissions are projected to reach 6.1 billion tons of carbon dioxide equivalent by 2050, representing more than 10% of global emissions. So, how can passive cooling make an impact? According to the UNEP Global Watch report published in 2023, passive cooling strategies can reduce the active cooling demands by 24% by 2050, which can bring the capital cost savings of up to $3 trillion while reducing emissions by 1.3 billion tons of CO2. These solutions are particularly vital for the population in the Global South, who lack the access to air conditioners and fans, which is currently estimated to be 1.2 billion people worldwide. Why nature-based solution matters? Nature-based solutions for passive cooling offer multiple benefits. For example, green roofs and green walls can reduce indoor temperatures through the process of evapotranspiration and shading. One of the studies in Saudi Arabia showcased that green walls could reduce building surface temperature up to 11 degrees Celsius and the surrounding temperature by 3 degrees Celsius, contributing to the reduction of cooling energy by 5 to 10%. Furthermore, these green infrastructure elements not only cool buildings, but also provide habitat for urban wildlife, improve air quality by filtering pollutants, and manage stormwater runoff, contributing to biodiversity and resilience in cities. So, where do we stand about global political commitments? The momentum behind passive cooling solutions is growing rapidly as international political commitments. At COP28, over 70 countries committed through the Global Cooling Pledge to establish national model building energy codes incorporating passive cooling strategies and energy efficiency strategies by 2030. Also, in the pledge, subnational governments committed to significantly increasing the area and quality of green and blue spaces in urban areas for cooling by 2030, in line with the Paris Agreement goals and Target 12 of the Kunming-Montreal Global Biodiversity Framework. Also, over 70 countries have endorsed the Déclaration des Chaillons, which is an international commitment to aim for the building decarbonization by increasing international collaboration, where it's explicitly identified passive cooling strategies as crucial measures for achieving net zero energy buildings and meeting Paris Agreement targets. The power of collaboration is needed. By bringing together the experts from across the world, this workshop exemplifies the collaboration we need to promote passive cooling approaches that deliver thermally comfortable buildings, while reducing energy demands and CO2 emissions in heat-stressed regions around the world. Today's workshop will allow us to exchange knowledge on existing passive cooling and nature-based solutions, and critically examine the benefits and challenges of various approaches across different climate zones, and collaboratively develop recommendations to promote wider implementation at both building and city scales. Lastly, passive cooling strategies are not new technologies. They have been used effectively since ancient times. The focus should shift from reintroducing or over-explaining these strategies to identifying ways to implement them more rapidly and effectively in today's built environment. This implementation challenge calls for unprecedented collaboration across the building sector ecosystem. For example, architects and engineers must engage in mutual knowledge exchange. Developers should draw insight from traditional builders who have long utilized passive method. Policymakers need to establish supportive frameworks and incentives to encourage the uptake of passive cooling strategies. Moving forward, it's critical to conduct cost-benefit analysis to understand the economic feasibility and long-term savings of passive solutions, and carry out the performance evaluations in diverse climatic and urban contexts to build trust and evidence among stakeholders, and use this data to inform clear, actionable guidance that accelerates real-world application of passive cooling strategies. Finally, I'd like to highlight that today's workshop results will be showcased at the 2025 United Nations Climate Change Conference, or COP30, in a passive cooling working group session in the Buildings and Cooling Pavilion to disseminate our valuable knowledge to the world. Thank you very much, and I hope we'll have a fruitful discussion today.